Well, we're looking at Calculus 1, integration, and under integration we're going to be looking at how to use the second fundamental theorem of calculus. And this kind of looks maybe intimidating to some people, but I promise you it's not that bad. Let me just go ahead and state the second fundamental theorem of calculus. F, of course, must be a continuous on an open interval I containing A, here's A, then for every x in the interval, this is true. And I've got some problems down here that we're going to be working here. Find f prime of x. Now, before we even get started utilizing this theorem, I'm going to go to the board and work a problem here. Let's say that we have f of t and it's equal to t cubed. We're on some closed interval between 0 and x. So just some arbitrary x. I want to find the integral between 0 and x of t cubed dt. And we're going to call this f of x is equal to, remember what this was, the antiderivative. So we should all know how to take the integral of this. This is just going to be t to the fourth over 4, and we're going from 0 to x. And so now we plug in our upper bound, so this is x to the fourth over 4 minus 0 to the fourth over 4, and of course, right, that's just all 0 there, so, but I went ahead and didn't skip that step. So capital F of x is equal to x to the fourth over 4. Well, let's say that right here we were actually asked to find f prime of x. So we're given this piece and we want to find f prime of x. Well, we'd have to take the integral of it first, and then, well, we got our f of x, capital F of x, but what we'd have to do now is, if we wanted to find f prime of x, we would have to take the derivative of this. And let's just do that. So f prime of x is equal to, so this becomes 4x to the third, whoops, over 4. And of course our 4's cancel out, and it's equal to x cubed. So f prime of, not t, but x, is equal to x cubed. Isn't that what we started with? Well, we changed our variables, but as you can see here, this is t cubed, and if we just did a switch of variables here and let x equal t, right, we could just switch this around as f prime of t equals t cubed. And of course, remember that f prime of t is equal to f of t, something we talked about earlier. Anyway, however, we're going to run into a situation here where we're not going to be able to take the integral of this. We may not have any techniques of taking the integral of this integrand here. And so we're going to use the fundamental theorem of calculus to do that. Plus, these guys up here may not be nice. Like, for example, that's x. That could be x cubed or x to the fourth. Okay. So we're going to utilize fundamental theorem of calculus and look at some others. We're going to work a problem now, or I should say an example. We're going to look at this one here. We want to find f prime of x. In other words, we're going to take the derivative, I guess you could say, of both sides, but we're going to take the derivative of this integral. That sounds scary. Alright, let's all remember what that says now. So the goal here is to find f prime of x. Now we're given, go ahead and rewrite it up here, f of x is equal to the integral between -1 and x, and this is our f of t in here, which I'm just going to go ahead and write the square root of t to the fourth plus 1 dt. We want to find f prime of t. Now remember what the fundamental theorem stated. We have d over, we're trying to take the derivative with respect to x. I went ahead and just wrote this in. This was part of the theorem here. So we're taking the derivative of all of this, and it is equal to f of x. So this piece right here, our f of t, is equal to the square root of t to the fourth plus 1. So you must be saying, well, let's just plug an x in here and be done with it. Well, that's all we have to do, actually. And remember, we're trying to find f prime of x, and remember that f prime of x is going to be equal to f of x. That was something we stated 3 hours ago, or however it was. So this ends up becoming, so our f prime of x is just becomes the square root, plugging x in here, x to the fourth plus 1. Now this is good if this is just x to the first power up here, and of course it is. It's just x to the first power. Okay, so that's pretty simple. You just take this and plug it in for an x. But if this is not to the first power and this is squared, or some other number, which we're going to work here in just a minute, you're going to have to use what's called substitution. We're going to look at this trig function here, cosine t. So let's look at this one here. Remember what this is, and we want to find f prime of x. Now you notice this is x squared up here, so we're going to have to do something different. So we got the integral from pi halves to x squared of cosine t dt, and that's going to be equal to f of x, and remember we want to find f prime of x. F prime of x. Well, I think we talked about at some point in time how to take the integral of cosine t. In this particular one here, we're going to use what's called substitution. We're going to let u equal x squared. Now I'm going to kind of skip some complicated steps. It's probably necessary to learn them, but we just want to get the answer here. I'm letting u equal x squared. We're going to, I'm going to rewrite this. And this is going to be equal to our f prime of x, which we're wanting to find here. Okay. And I'm going to say du, or d over du, and we're taking the integral between pi halves and u. So you see we substituted this x squared here for the u. Right. And we go ahead and just rewrite everything else. Cosine t dt. I need to close that bracket. Close that down there. Goodness. And we're going to put the du over dx out here. Now to get du over dx, we're going to take the derivative. So we have du over dx is equal to I think my eyes are going bad. That's supposed to be a 3 there, but hold on just a sec. Thought I wrote a 3 in the problem, but that's just a 2 there. Okay. Doesn't matter. This would be 2x. There we go. Okay, so by the second fundamental theorem of calculus, this piece right here is going to end up becoming just cosine of u times, and then we have the du over dx, which is 2x. And guess what? This is equal to, we're just carrying this down, f prime of x. But don't leave a u here. We need to go back and substitute back in, so this becomes cosine of x squared. And I guess it'd be appropriate to bring that 2 over there, I suppose. Now what you could do, instead of going this route, you could go ahead and take the integral of this. And once you take the integral of it, then take the derivative, and you should end up with this exact same piece here. In fact, let's just do that. Let's take the integral of this, and I guess we'll just go on down and rewrite this. The integral from pi halves to x squared of cosine t dt. So remember what the integral of cosine t is. It is sine t, and we're going from pi halves to x squared. So now what we're going to want to do is go ahead and plug our upper and lower bounds, our upper bound and lower bound in sine x squared minus sine pi halves. And remember, this is all equal to our f of x. Now, what is it that we were wanting to do earlier? We were wanting to take the derivative of this, right? So f prime of x is equal to, now the derivative of sine is going to be cosine of x squared, and then of course we have to take do the chain rule, take the derivative of this and chain it outside, which is 2x. But what is sine of pi halves? Well, remember, sine is the y coordinate, and pi halves is up here. Pi halves is up here, so this becomes actually minus and then 1, right? 1. But when we take the derivative of a constant, we get 0, so there we are. We're left with cosine x squared 2x. What was our answer up here? Cosine x squared 2x. Of course, I brought the 2 out front. But here's the question. Will you be able to take the integral of this? And chances are, if you're taking a test, they're going to set this up so you can't take the integral of it. So you'll just have to do the substitution and follow the steps. It's pretty easy. And we're going to actually work another problem. We got time. We're going to look at this one down here, which this is another one that we could actually take the, take the integral, take the derivative, and so forth. But we're going to go ahead and do this one here. Alright, so what I'm going to do is I'm going to let u equal the x plus 2, and we're going to also need to solve for x in this problem. U minus 2 is equal to x. But by taking the derivative of this top one up here, we'll write this down here, you get du over dx is equal to, let's put an arrow here, So we have identified our u, but then we've got this issue down here with x. Well, what you'll have to do is you're just going to have to bring this 2 over and solve for x, and then we'll do the substitution. So now's the time to actually do that substitution. We'll just go ahead and do that. So this becomes u minus 2, and this is u. But we're still rewriting the same thing inside here for the integrand. dt. But now remember, this is all times the du over the dx, which is just a 1 here. It's just a 1. Now, of course, what we'll want to do is plug our u in. So remember, this becomes 4u plus 1, and I'm going to put a parentheses around this, minus, and we need to do our lower bound, 4 times u minus 2 plus 1. And of course, remember, this number here is just a 1, but this would be multiplied by all of it. But what we can do now is just simplify this down. So we have 4u plus 1. We can distribute this 4 across. We have minus 4u plus 8. And then, of course, we have a minus 1, right? Distributing this minus to this 1 here. Well, as you can see, our 4u's cancel out, our 1's cancel out, and all we're left with is an 8. So f prime of x is equal to 8. Well, this might be confusing, but just stick with the theorem. These were 3 examples worked out. I hope it helped you out. If you want any more of these examples worked out, just let me know and send a comment. Hey, and also subscribe, because I guess that's what people do. Anyway, thanks.